order of operations. Our objective is to use the order of operations to simplify expressions. Why learn this? Sports statisticians use the order of operations to calculate data. Let's look at what the order of operations is. So we start with parentheses and grouping symbols. That's step 1. Now, we don't move on to step 2 until we don't have any more parentheses or grouping symbols. So in step 2, we've got exponents. In step 3, we're multiplying and dividing from left to right. Just because M comes before D does not mean you multiply before you divide. You multiply and divide from left to right. So whichever one comes first is the one that you do first. Same with step 4. Add and subtract from left to right, which means whichever one comes first is the one that you do first. So you add and subtract. If you happen to hit subtraction first, going left to right, then you subtract before you add. Let's practice. So we have -4 squared plus 24 divided by 3 times 2. Do we have any parentheses or grouping symbols? No. So now we're moving to step 2. So with step 2, we have exponents, and we do have an exponent here. We've got this -4 squared. So 4 squared is 16, and we keep the negative off to the side. All right. Do we have any more? Do we have any parentheses? Nope. Any more exponents? No. So now we're moving to step 3, which is to multiply and divide from left to right, which means whichever one you come to first is the one that you do first. So we have any multiplication or division? Yes, we do. We happen to hit division before we hit multiplication, so we are dividing first, because it's multiplication and division from left to right. So we have 24 divided by 3, which gives us 8. All right, is there any more multiplication or division? Yes, we hit multiplication. So we have 8 times 2, which gives us 16. Is there any more multiplication or division? No. So now we're moving to step 4. So in step 4, it's add and subtract from left to right. In this case, all we have is addition left. So we're going to do -16 plus 16, which brings us to 0. Let's try this next problem. So we have 4, and then we have inside a set of grouping symbols, we have 25 minus another set of grouping symbols of 5 minus 2 squared. Whenever you have multiple things going on inside of parentheses, you're going to go to the innermost set of parentheses and then follow your order of operations with that. So see, you have your parenthesis around this 25 minus quantity 5 minus 2, that quantity squared. So this is the set of parentheses we're going to look at first. So we're going to kind of ignore the 4's existence for a while. All right, so inside this set of parentheses, do we have any other parentheses? Yes, we have 5 minus 2. So we're going to start with that, which gives us 3. So we have 4 times the quantity 25 minus 3 squared. We're still inside this set of parentheses. Are there any more parentheses? No. How about exponents, since that's our second step? Yes, we have 3 squared. So you're going to take care of that next. So now we have 4 times the quantity 25 minus 9. And then we're still working within these parentheses. So 25 minus 9 brings us to 16. All right, so we don't have any more parentheses or grouping symbols. No exponents. Now do we have multiplication and division? Okay, we do. We have multiplication. So 4 times 16 brings us to 64. Let's try evaluating algebraic expressions. So evaluate each expression for the given value of x. That means we're going to have to substitute. So we can substitute, in this case, 7 in for x. So we're going to have 21 minus 7 plus 2 times 5. All right, are there any grouping symbols? No. All right, so on to step 2. Are there any exponents? No. So now we're on step 3. Is there any multiplication or division? Yes. We have this 2 times 5. So 2 times 5 is 10, and then we simply rewrite the rest of our equation. It's really important to write out all of your steps as you do this. Okay, so now, is there any more multiplication or division? No. So now we're on addition and subtraction. Keep in mind, it's addition and subtraction from left to right, which means whichever one you come to first is the one you do first. So we hit subtraction first. So 21 minus 7 is 14. And then rewrite the rest of your equation. So you have 14 plus 10, which is 24. Take a moment and pause the video and try B. Now that you've had a moment to try B, let's try it together. So we're going to substitute 24 in for x. So we have 5 squared times 30 minus 24. And now we can begin evaluating our expression. Woohoo! Alright, so do we have any parentheses? Step 1 in the order of operations. Yes, we do. So we need to take care of what's inside those parentheses first. There's only one operation, so not as crazy as one of the last problems we just did. So 30 minus 24 is 6. And that is being multiplied by this 5 squared that we're going to rewrite. Alright, so do we have any more parentheses that are grouping things together? No. The only thing we have, these parentheses are just being used to symbolize multiplication. Alright, so our next step, step 2, is exponents. We do have exponents. We have this 5 squared, which is 25. So we have 25 times 6, and then no more exponents, so now we're on step 3. So we're going to multiply or divide from left to right, and we just have multiplication, so 25 times 6 is a nice 150. Let's try simplifying expressions with other grouping symbols. These are a little bit more challenging, but they're not too bad. Now, when you're dealing with a fraction with multiple things happening on the top and the bottom, it's assumed that there is a set of parentheses kind of grouping them together, even though they weren't nice enough to draw them in for you. So, with that being said, we can now simplify inside of each of our parentheses. So we're going inside this set of parentheses on the top, our numerator. So, do we have any more grouping symbols within this one? No, so now we're going to step 2. Do we have any exponents? Yes, we do. We have 2 squared. So we've got negative 22 minus 4. We're going to keep those in grouping symbols. And let's look at the one on the bottom now. So we'll do that in red. So do we have any extra grouping symbols within this set? No. How about exponents? No exponents. Any multiplication or division? Nope. So now we're on step 4, addition and subtraction, and we do. We've got 5 minus 3, which brings us to 2. Alright, so now we still have a set of parentheses we need to take care of, because that is step 1 in the order of operations. So we have negative 22 minus 4, which is negative 26, and we're going to rewrite our 2 down here. And then we can simplify this. It's only one operation left. So we're just going to simply do negative 26 divided by 2. And in that case, we end up with negative 13. Take a moment and pause the video and try B. Now that you've had a moment to try B, let's try them together. How many of you guys realize that this absolute value set of symbols here can be thought of as a set of parentheses when you're trying to group things together? Alright, so let's think of these as a set of grouping symbols. So we want to take care of what's inside of them first. So do we have any more parentheses inside of those? No. But we do have exponents, which is our second step in the order of operations. So we have 10 minus 25. We do need to keep those absolute value symbols. And we have divided by 5 that we're going to simply rewrite. Alright, so inside our grouping symbols here, we still have this group of 10 minus 25. It's all we have in those grouping symbols, so we're just going to subtract those two. There's no extra parentheses, exponents, multiplication, or division, so we're going to step 4 here. So we have 10 minus 25, which is negative 15. And it's still inside those absolute value symbols. And now we can take care of what is the absolute value of negative 15? Well, the absolute value of negative 15 is just positive 15. So 15 divided by 5 is 3. Let's look at translating from words to math. So translate each word phrase into a numerical or algebraic expression. Alright, so we'll do the first one together, and then I'll have you guys try B on your own, and then we'll do it together after you've had a chance to try it. So we have 1/2 times the difference of negative 5 and 3. So you have 1/2 times the difference of these two. So it's 1/2 times this quantity together, because it's the difference of negative 5 and 3. So 1/2 times the difference of negative 5 minus 3. Try the next one on your own. Now that you've had a moment to try this one on your own, let's try it together. So we have the square root of the quotient of negative 12 and n. So you have the square root of the quotient. Quotient means division, if we recall back. So we're dividing negative 12 and n. And it's the square root of this quantity together. So it's the square root of negative 12 over n. And that would be that one. Let's look at a sports application. Hank Aaron's last season in the major leagues was in 1976. A player's total number of bases can be found using the expression S plus 2D plus 3T plus 4H. In case you're wondering, it's single, double, triple, home run. Use the table to find Hank Aaron's total bases for 1976. So for singles, he hit 44 of them. For doubles, he hit 8. For triples, he hit 0, but he hit 10 home runs. So we're going to substitute each of those values in. Now we want to use the order of operations to make sure we get an accurate number for Hank Aaron's total bases that he ran in 1976. Alright, so multiplication or parentheses, nope. Exponents, none. So now we're going to multiplication and division. So, do we have any multiplication or division? Yes, we have 2 times 8, 3 times 0, and 4 times 10. So we have 16, 0, and 40. And now we have no more multiplication or division. But we do have addition or subtraction. In this case, it's addition. So we can simply add as we go across. So we have 44 and 16, which gives us 60. So we have 60 plus 0 plus 40. Well, 60 plus 0 is just 60. So 60 and 40 make 100. Therefore, Hank Aaron's total number of bases that he hit in the year 1976 was 100 of them. And that concludes our lesson on orders of operations.